right, welcome to today's presentation. My name is Jeremy Snyder, and today I'm going to be talking about API security. What is it, why you should care, and how to protect your organization. As you will have seen, this is a re-recording of a session done recently at UK Cyberweek in London. So just to kind of kick off today's presentation, what we're really going to talk about today is a little bit of the context for APIs, why they are so important right now in 2023 in the kind of modern internet landscape that we all live in, why you should care, why they're important. We know that they're rising. We're going to talk about that, and we want to talk about why they're important and you really should care about API security, and then some advice about taking steps to protect your organization and its APIs. This is just a little bit about background on me, how I ended up where I am today. Don't worry about that too much. Let's focus on kind of the subject matter for today, and that is APIs. So let's set the context for APIs. What's going on in the API world right now? Well, frankly, APIs are everywhere. Every mobile app, every time you pull out your phone, you open up an app to, let's say, order a ride or food delivery or whatever, there's very little that's actually happening on the mobile device itself. All that's really happening there is kind of a front-end interface that allows a transaction to be kind of created and structured and then transmits that transaction to a backend, probably living somewhere in the cloud. And that itself is an API connection between the phone, the mobile app, the device, and the backend. That API call gets sent out, and that triggers a whole wave of business processes. That can be business logic, that can be data manipulation. We'll talk a lot more about that as we go. On top of that, every IoT device, there's very little in the way of intelligence in, let's say, your smart TV or your smart refrigerator. All that's really happening there is a set of sensors and maybe a rudimentary interface on the device itself that is, again, communicating with the backend where all the kind of magic and logic happens, again, over an API connection. And in fact, if you're using SaaS applications today, the chances are really high that that SaaS application, even if you consume it inside a web browser, is actually two parts. There's what's typically called a front end and a back end. And the front end is really the display logic, and the back end is really the business processing logic. We also see kind of refactored enterprise applications, whether they are browser-based or desktop, and of course, cloud-native applications. They're really just a whole set of applications that have front-end UIs talking to back-end over APIs. It is, in fact, the backbone of the modern web. Little fun fact, and this is a little bit of a dated statistic, as of a couple of years ago, about 83% of all internet traffic was API traffic. So that is, systems talking to systems, your mobile device talking to a backend. It's not so much me using Google to look up some information or things like that. So there's a lot more kind of computer to computer communication going on than human to computer communication going on. And that is really the backbone of the modern web and kind of the world that we live in today. So I like to use the example of a mobile food delivery app to try to frame exactly kind of how critical this is and why this is important. So let's say that you are hungry, you pull out your phone, you start browsing some menus like dumplings, croque monsieurs, whatever, and you choose a menu, you choose some items off that menu, you click send, right? So that is the first API call. It's actually really not. There's a couple things before that, like authentication and whatnot, and location determination and so on. But let's just to say that in this order process, it's the first API call that's out, and it kind of sends an order to the backend. So that order gets processed by some company. That might be Just Eat in the UK, that might be DoorDash in the US, Delivery Hero, any number of companies or brands around the world that I'm sure you're familiar with. That gets processed in a number of different ways. First, we have to check whether the order should be placed. So we want to process payment and make sure that there's money available. Gift card, credit card, what have you. But let's assume that for most of the time, it's a credit card. Well, typically, that's not going to be processed by the same company that actually places the order. What they're going to do is they're going to interface with a third-party payment processing provider that takes that credit card, charges it, and then sends back a signal and says, yes, you can proceed with the order. We have received funds from Jeremy. So there's an API transaction happening over there that is sending things like my payment details, some payment tokens around that, amount, credit limits, all of that kind of stuff can be included in those calls. That's very, very sensitive data. Next, the order needs to be sent to the restaurant. The restaurant should ideally acknowledge the order, accept the order, confirm it, whatever the language might be on the app that you use, but you'll often see that where, your order has been sent, waiting confirmation. So there again, we're sending information to the restaurant about the food that we want. Then finally, now the central app, DoorDash, Just Eat, whatever it is going to communicate a delivery service. That could be a driver, bicycle rider, what have you. That is sending your personally identifiable information, your PII. So that is things like your name, your phone number, your home address, much more can be in that package. So the point of this is to explain, first of all, just how complex a lot of modern interactions are. What we think of as one order that we submit has actually kicked off probably in the neighborhood of 20 to 25 API calls in order to successfully complete that transaction or successfully process that order. Second, I want to emphasize just how much critical information is in there. So we've got home address, we've got credit card details, et cetera. Third, I want to emphasize the criticality of the business transactions that are happening over APIs. So when we think about this order, in order for this to complete successfully, and granted, this is not a life and death type of transaction, but it is crucial to that business that all of these parts work and they work together. We think about needing the payment processing, and we think about needing the restaurant order to be accepted, confirmed, and updated as it's prepared, and so on. All of that actually has to work together. So those are critical business transactions, and that is a key part of the business logic that processes this order. All of that has to work together, and all of that works over APIs. So I want you to keep that in mind as we go through today's presentation and we talk about, why you should care about API security. It's because actually so much critical information and so much critical business processes are being transacted over APIs. APIs have been on the rise actually for quite some time now. So some of these statistics go back to about 2020 or 2019 even. We know that private APIs are actually higher than public APIs. So if you think about a company that is exposing one or a few APIs to the public in order to, let's say, create an ecosystem effect, behind those public-facing APIs, they have likely, maybe double the volume of APIs for private parts of processing that same application or that same business logic. We know that there are about 200 million public APIs on the web today. We expect that to grow to over 1 billion in the next couple of years. The API economy itself is already quite large. So there's a number of companies that you might have heard of, but you never really understood what they did. But there are a number of companies that either provide some kind of business process transaction. Let's say in the case of Twilio, things like sending an SMS with a password verification code or something like that. These are services that are provided exclusively via APIs. And the chances are very, very high that you're interacting with these already on a daily basis. I think it's really not a stretch to say that, we are on track to having 1 trillion APIs in the coming decades. So all of this is going to be even more important going forward in the years to come. There was a great report that came out in 2021. If you are interested in a lot of the background information, I do encourage you to read that. It's actually from Akamai. It's the State of the Internet Report 2021, which really, really focused heavily on API. So if you're looking for background information on some of the things that we'll talk about today, definitely that's a good place to go check out. So let's talk about kind of APIs themselves from a technology and architecture perspective. How did we get to where we are today, and why are APIs so popular today? If we go back to the 90s, we already had ways of interchanging data from company A to company B. Primarily, we used something called EDI, electronic data interchange. This was a nightmare of a format. I'm old enough to have been around for some of these transactions and seen multiple companies interacting with each other over EDI. You mostly use things like, let's say, batch FTP or secure FTP if you were a little bit more cutting edge back in those days. Very much what we would call kind of the web 1.0. Company A sends a file to company B receives that file, imports it, processes it, drops it into a piece of software running on a server somewhere, and that's how it happens. We were primarily in data centers and colo facilities at those times. So it was pretty uncomfortable and pretty inconvenient to do a lot of this. And so in the 90s, you didn't see as much of this, party-to-party interaction and communication. Then we got into the 2000s, and actually Microsoft was one of the companies that really kind of pioneered this movement in the 2000s. You would have seen something called SOAP and XML. They talked a lot about web services at the time. If you were maybe working in technology at that time, you would have seen a lot of hype around web services and the potential of them and how they were going to transform business. It's really interesting in my mind that, Microsoft was one of the pioneers in this space, because I think actually if you fast forward to where we are today in the 2020s, what we actually see is open source technologies have really surpassed, kind of Windows-based systems in terms of this. But we started to get better and more efficient with APIs in the 2000s. We had the rise of something called SOAP, Simple Object Access Protocol. It was a way that, you could publish a web service and make it available for people, and then publish a set of requirements and constraints. There was a concept called the DTD, a document type definition, that you would use in order to interact with an API. We started using XML as a markup format that was very standardized. And we started to see more of these kind of client-server interactions. The difference being from, let's say, from the 90s was very much, let me push something to you, and then you're going to take it and you're going to process it, and maybe you're going to give me something back at the end. When we get into client-server, we can start to maintain some connections. So we can have remote processing done by a system somewhere out on the web and local consumption on our desktops or things like that. We started to see the rise of virtual machines, both in terms of virtual desktop and in terms of virtual servers. So things like VMware became very popular around this time. This made it a lot easier to stand up these services, a lot faster to create servers and to create environments where we could run them. When we get towards today in the 2020s, the technology and let's say the barriers to adoption are like almost gone. It is so simple to get started with an API-based service today or launching an API. You can, in fact, drop your software code directly onto a cloud platform like AWS or Microsoft Azure. They have serverless functions. They have container environments. You don't even have to run a virtual machine. You can literally drop your business logic code out there and create an API directly from your business logic and from your application code. We've gotten into a very distributed API-centric world where things like that food delivery app example that we talked about a few minutes ago are possible. And that's happening in real time among multiple third parties and partners that collaborate in order to facilitate just one business transaction. We've gotten a lot better and more efficient with the way that we interchange data as well. REST has kind of become the standard. We really use, HTTP protocols. We use JSON as our document interchange format. We are seeing, by the way, a rise of GraphQL. GraphQL is a little bit of an alternate technology for creating APIs. REST typically has you define some constraints about how you interact with an API, especially when it comes to things like data queries. GraphQL is a lot more liberal on that side, allows you to create a data consumption service even quicker than with REST. So we're getting a lot more efficient, and it really is enabling the modern web to be this kind of set of building blocks where any type of functionality you need or any data that you need, the answer really is there is an API for that. Just like, 20 years ago, or maybe a little bit less, we would have said, hey, there's an app for that. Nowadays, you can say there's an API for that. So with all of that background, what is API security and what do we need to be thinking about for it? Typically, when we see a new technology, and I've been in the cloud for about 13 years now, we see a set of kind of common patterns and behaviors. One is that development teams and architecture teams tend to get ahead of security teams. And what that leads to a lot of the time is that security teams don't have visibility. They don't really have an inventory, so they don't know what's going on. Secondarily, we see that security teams, when they try to wrap their arms around this new technology, they have a heavy focus on perimeter security. Why? Because that's how enterprises have behaved for a long time, and especially enterprise security teams. They're very used to firewalls, and what we're finding with APIs, especially those built on the cloud, is you can't really take that same kind of firewall approach to it. So you start to see more of these kind of newer network constructs like API gateways, web application firewalls, application load balancers, et cetera. Then we realize that we have a lot of challenges with the API itself when it comes to, let's say, the business logic that it exposes or the data that it exposes, and we need more traceability from the application that is actually running in production back to the team that wrote it. We don't have a common set of understandings around how to securely configure a network or a server environment specifically for the goal of producing a secure API. So we have some best practices around kind of common server security, around common cloud security, but not specifically to APIs. Then we have the kind of common challenges around change management that goes back to that point that I raised earlier about development and architecture teams typically getting ahead of security. And then that last point really kind of brings it home. There is kind of an organizational gap and often an informational gap as well that starts to build up some resentment. So when we think about organizations trying to manage new attack surfaces, and we'll call APIs and new attack surfaces, is something that is known, but now all of a sudden we've got a bunch of this stuff running public. We tend to see a common set of requirements or principles that security teams want checked in order to feel like they've got a good handle on the situation. Number one is kind of discovery. And I think the key thing to think about there is, there's this saying in security is that if you don't have visibility, if you can't see it, you cannot say that it is secure. So those two first points, discovery and visibility, really go hand in hand on that. The second thing is, once you've got discovery and you've got visibility running, it's really observability. Can you see what's actually happening? You know that it's out there. So you've got that visibility into the fact that it exists, but can you see what's actually happening? How many success failure events are we having? How many events are we having where it looks like maybe somebody's trying to break in or who knows what? Next, once we've kind of gotten through that step of establishing that baseline visibility and observability, a lot of organizations tend to want to focus on kind of enforcement and policy. So now we come up with a set of rules for what we think is secure for our APIs in our organization, and then we want to enforce those rules. So those next 2 points, enforcement and policy, tend to go hand in hand as well. And then last but not least, and I think this is a point that really needs emphasis, is audit. So APIs are a tricky kind of thing because they are part of an application construct, and they're part of a construct that can actually live on a number of different environments. So if I think about where I can run an API, I could run an API anywhere from my desktop to a server in an office, to a server in a data center, bare metal, virtual machines, data center, co-location, on the cloud. And even on the cloud, I could run it on a virtual machine. I could run it on a container. I could run it in a serverless construct. And all of those things I could run either raw natively exposed to the internet, or I could put any number of network controls in front of them, like load balancers, application firewalls, and API gateways. And so I've got all these different kind of configurations. And one of the questions is, how do I know what has actually happened? Do I have visibility onto the activity, not just the observability, but do I have a centralized audit trail? And when we think about an audit trail, what we really want to know is we've got kind of this, write once, read many, WORM, if you're familiar with that acronym, place to look at our API transactions. What was requested, what was returned? Because that is kind of how APIs work. If you've got a request and you've got a response. And if you're trying to think about that day that comes when you do have an API breach or you've got an incident on one of your APIs, in order to understand the impact, you really need to have that audit trail. So let's talk about what we've learned from API data breaches. So team at FireTail, we've actually been putting together a record of all of the known API breaches that we could find online. We've been tracking this for a couple of years now. The attacks go back to 2013. And we see actually close to 1 billion records at risk exposure. We're going to throw another stat in there later on that there's actually about 500 million, over 500 million that have actually been exposed, and more closer to 1 billion that have been at risk at exposure. The gap there is actually those that have been kind of disclosed by security researchers and quantified. And so we've captured those as well to help understand. So API attacks have grown about 350% over the last couple of years. I just picked one statistic, which granted is about 2 years old, but it really shows the rise of these. So there's been a relatively low volume up until that point in time, and it's really accelerating. And then I think something that's important to understand is that, when we look at the breaches themselves, and we're going to talk about some of the root causes in just a second here, we find that it's actually vulnerabilities in the apps. It's not like a brute force. It's not like actually, let's say, hacking. There are a couple of cases of injection, but for the most part, it is things like application logic that produce the problem. So let's dive into some of that. Our friends at Gartner actually predicted that last year would be the year that API abuses will be the most frequent attack vector. Not quite yet. I still think business email is really, business email compromise, phishing, et cetera, is really the #1 attack vector, even for, let's say, introducing malware and ransomware into organizations, but API attacks are definitely on the rise. Okay, I mentioned a couple minutes ago when we talk about like actual breach data, we've got about 577 million records or more that have actually been breached. One thing that's really interesting is that the number of records per breach is pretty high. So when we see these problems with APIs, they tend to be systemic problems. They affect the entire API. So that's why the number of records per breach event is quite high. We've had 43 unique events, and the top attack vectors can be broken down into a couple categories. The top two, by some margin, are actually authentication and authorization. A lot of people think those are similar or the same thing. They're kind of not. Authentication is, let's say, establishing that I am Jeremy. Authorization is then checking, is Jeremy allowed to do this thing? And that can be, is Jeremy allowed to see this data? Is Jeremy allowed to, let's say, update this data, request this data, delete this data? So it can be either data access or functional access. And both of those actually turn out to be pretty important over the course of the API breaches that we see. So we know there are logical flaws because those are actually implemented by application logic, both authentication controls and authorization controls. But there's actually a little bit more that goes into them. When we look at kind of secondary attack vectors, we actually see there's a coupling. So authorization may have been the primary attack vector for quite a lot of them, and then authentication being a secondary attack vector. We also see things like governance, and we see data exposure being very, very high. So governance often refers to situations where we had something like what was intended to be an internal API that got accidentally published online out to the public internet. And then data exposure tends to be things like let's say a form in a mobile app that displays your first name and your last name. But in order to make it easier, the developer actually requested your entire data record. So the API request may have given back not only my first name and last name, but my home address, my email address, my phone number, et cetera, and just relied on the mobile app to not display that data. That turns out to be a pretty large secondary cause of data breaches in a lot of the cases. So the point that we want to make there is actually for most API data breaches, they're multi-vector, meaning more than one thing went wrong. It's not that the attacker, let's say, necessarily strung together multiple vulnerabilities. It's that multiple failures kind of led to the exposure of the data. APIs are everywhere, so there are not really industry-specific things, but there are 3 industries that have had, let's say, an oversized impact on the number of records breached in the recent history. Automotive in particular. So if you've got a smart car or a connected car, I don't mean smart the brand, but I mean a connected car, you may want to look at whether there is a firmware update for your car, especially if it's one of the brands that have had disclosures in the last 3 months. That does include a broad number of brands. You can find more info on our blog. Of course, software companies that are making SaaS applications, mobile apps, et cetera, are a huge category. And then hospitality. And if you think about this for a second, this actually really computes. Go back to that example of the mobile food delivery app and then think about how you order things like tickets. You may go onto an aggregator site like an Expedia or a Booking.com, and you've got availability of airlines, hotels, rental cars, et cetera. Well, how are they interacting with all of those third parties that they, let's say, book you tickets or reservations for? Through APIs. And so we've got a lot of API interaction in the hospitality space. And as a result, we definitely see breaches around hospitality. If you're interested in the data, please feel free to check it out. This is linked from the foot of our website. Feel free to check that out. So let's talk about how to protect your organization and some of the observations that we've had, some of the, let's say, successful strategies that we've seen from people. So first is actually go back to those core principles. So start with discovery, start with visibility, bring all of that stuff together and, try to begin a process. And what we've seen from a lot of organizations that it's worked well is they go through that discovery and inventory phase, they do some observation of the APIs, and then they move forward onto the policy side. Once they move forward onto the policy side, they've got a couple of options. So some things they can just go directly into an audit mode because they realize either those are potentially lower risk or it's harder to implement runtime protection on them. And then others that are either higher priority or they feel like they've got the technical capabilities, they do implement runtime protection. Runtime protection can take a number of flavors. That can be anything from a few of those network controls that we talked about actually provide some layer of runtime protection, but more often than not, it's coming to a specialized tool or a specialized bit of application code that can help prevent those API breaches. So that's one of the patterns that we've seen. And let's say you get through all of that and you're ready to move on to like more advanced API security. What we've seen as some really strong initiatives with some organizations is to really build an end-to-end API security strategy. So if you think about, from the point that an API is conceived by a developer or conceptualized by a developer to the point that it gets into production, there's a number of things we could do. So first, we could make sure that everything we're doing to build that API is secure. So good source code practices, eliminate vulnerabilities from, let's say, third-party libraries and so on. Then before we launch, let's do some fuzzing and some logical tests around our APIs. Let's assure that our APIs in a staging environment are not exposing too much data. They're doing the right authentication and authorization checks and so on. They're not misbehaving if you give them weird request parameters that they don't expect and things like that. And then finally, when we get into production, we think about, runtime protection. We really do think about kind of the top 4 attack vectors. So we talked about authentication and authorization being there. We've also seen, kind of probing and enumeration being very high, a little bit of injection. And then another thing really is on, excessive data exposure. So make sure that you're not sending back too much data from your APIs on the server side to whatever client is requesting them, whether that's a mobile app, et cetera. And then another thing is, focus on that centralized audit. And then DNR, what that stands for here is detection and response. So a number of ways that you can look at that. You can set up alerts when you see certain conditions in logs. Maybe if you see some PII in a log where you don't expect it, you could create an alert and the security team could act on that. And then if you really are ahead of the curve and you're saying, hey, we're doing all that already, we want to really kind of like improve the efficiency of our operations team. We'll then integrate API data with something like your CNAP, which is where you're probably doing a lot of your cloud security, or maybe with an application security program owned by a product team. So they got understanding of not only, let's say, the vulnerabilities in the application, but what they should do to improve the security of the API. That's kind of the front end of that application. And then also think about integrating with security operations tools. So that might be, let's say, a ticketing system, a centralized logging system, or a SIM, or that could be something like, real-time alerts and notifications. Whatever works for how your security team is going to react appropriately to the potential events that you're having. One point that we'd like to make from the FireTail perspective, and we've been kind of analyzing this for a little while, we really think that you need to focus at the application layer if you want good kind of universal runtime protection. The reason for that is, we took this example from AWS. We took 3 different types of log files, 2 out of AWS and 1 from FireTail itself, and we kind of compared the visibility that you get. And you realize that when you're focusing on things like authentication and authorization, you really need to be kind of one level higher in order to see things like your authentication headers, and you need to see, let's say, the arguments that are passed to the API, the request parameters, et cetera. And if you want to see what goes back in response to the API call, you've got to sit at that application layer. That also means that you've got visibility into things like authorization logic. So if you're trying to eliminate some of those real risk categories, that's kind of where you've got to be. So if you are interested, please feel free to check out FireTail. We do actually provide an open source security library that you can drop into application code. It is available in 4 languages. You can actually find that on our GitHub in the open source form. And of course, we offer free trials for anybody who is interested in that. Okay, so let's summarize. What is API security? Why should I care? How do I protect my org? So what is API security? It's really the safety of the most critical interfaces, maybe not yet, but soon to be. And we really do believe that that will be the case for more and more organizations as they either shift to the cloud or they go through digital transformation, what have you. Why should I care? Breaches and attacks are rising. They're already large and they tend to be systematic. So when there is a problem, it tends to expose an entire database or an entire data set. How do we focus on API security? Always start with visibility, then focus on protecting what you believe should be protected and making sure you audit the entire event. So that is it for today. I thank you for taking the time to watch this. I hope you found this valuable. Please feel free to reach out to me or the team anytime if you have any questions. Also, the slides from today's presentation will be on the blog that will also include this video. Thank you so much.